All right, so this is special right triangles, the 45, 45, 90 triangle. So we've already been over whenever two of the angles are the same, that means also two of the sides will have the same length. So another name for a 45, 45, 90 triangle is an isosceles right triangle. Isosceles meaning two sides are the same, and right because one of the angles is 90 degrees. All right, so I have a theorem, and the theorem is in the 45, 45, 90 triangles, both legs are congruent, and the length of the hypotenuse is square root 2 times the length of a leg. And I have a very easy way of calculating this. But first, we're going to go through the theorem. So if this side is A, down here, and the other leg is also A because they are the same, because that's what's across from the two 45s. And the hypotenuse is going to be square root 2 times the length of that side, which we're calling A. So this is square root 2, or no, A times square root 2. Because you always put the radical part second. And I just chose A. Normally you would see an X, but in a lot of your problems, you tend to get more X's than you do A's. And if you have X representing two things, it makes it confusing. So A is not as commonly used in the problems that you're assigned. If you are assigned a problem, such as like number 3 on your assignment that has an A, I would just change that A to something else so it's less confusing. An X, a Z, whatever letter you want. All right, so that is the official theorem, and you could draw it out and do it that way if you like, but I'm going to show you a very simple method. I call it the tic-tac-toe method. And you start by creating a chart, a tic-tac-toe table. And we're going to have a different one tomorrow for the 30, 60, 90 special right triangle. But today we're dealing with 45, 45, 90. So in the first column, I'm going to put 45, 45, and 90, representing the angles of the triangle I'm solving for. All right, so this is the angle of the triangle. So you don't have to label this every time, but I am for this one because it's the first time you've seen it, explaining what I'm doing. So that's the angles of the special triangle. The next one is going to represent the sides. And so just like in the theorem above, we have A is the side length of a side across from 45 degrees. So I put an A for that side and A for the second side because it's also across from 45 and we know that they are the same. And then across from 90, I'm going to put A square root 2. So that matches the theorem. So we're doing the same thing as in the theorem, just in an organized graphic way. And then the second line of the tic-tac-toe represents sort of like an equal sign. And that's the part you're solving for is the last part. And that's your answer. I don't really have a clever name for that. And it's the answer. It's also the side, but it's like the number value of the side, what's missing. So every time you set it up like that. And you have to be given at least one piece of your triangle in order for this to work. Or otherwise, you have nowhere to start. So that's what it's going to look like. So each one of these is like an equals. This whole line is like the equals line. So it's A equals A square root 2 equals. All right, so it'll make more sense as we go. All right, so first, I see I have a 45, 45, 90 triangle, so I'm going to set up a tic-tac-toe grid. And this is a 45, 45, 90. You do have to pay attention to which one, because like I said, tomorrow we're going to deal with 30, 60, 90 triangles, and those will have different A values. So you have two different tic-tac-toe grids, and I will give you those on the test. I'll have them written on the board. You don't, I mean, you should have this memorized by the time we get to the test after just practicing it, but I will give it to you also. Yes. So A square root 2. All right, so then after you have it set up, you look at your problem and see, what do I have? Well, the only thing I have is the 6. N and M don't really help me solve for anything. Those aren't numbers. And B? Oh, no, we're not doing that. We're doing this is completely different. So the 6 is across from the 45 degrees. So go to the tic-tac-toe grid, and here's a 45 degrees. Across from 45 degrees, I'm going to put in a 6. And remember I said that represents an equal sign? So I know that A equals 6. So now if A equals 6 up here, what does A equal right here? Yeah, it also equals 6. And then, so what about the bottom row? If A is 6, what is A square root 2? Did A change? No. So wouldn't we just put in a 6 where A is? And the square root 2 is just already there, right? And it just throws you off because of the radical, but really, I mean, if that was instead of if instead of square root 2 right there, I had times 2, A times 2, would it be less confusing? Like A is 6, A is 6, A times 2, you would put 6 times 2, right? So you're just filling in. A didn't change. It's being multiplied by something. And since that's simplest radical form, we're going to leave it as 6 square root 2. And now we've solved for everything we need. So we do have to make sure we answer the question. And that's important. This says, well, it says find the value of x. The instructions should say solve for the missing variables. So n is across from a 45 degree, right? This would be 45. So what is the value of n? 6 from the chart. Yeah, because it's an A. N is A. And then M is across from 90 degrees. So what is M? Yep, 6 square root 2. And that's it. Now this is a straightforward, super easy version. It depends on what you have when you start filling in your chart as to how easy it is to actually solve for the missing piece. Sometimes they're this easy, super easy, where if it gives you the leg and you're solving for the hypotenuse. All right, let's look at another one. I see I have a special right triangle. So I'm going to set it up as a 45, 45, 90. And that's A square root 2. So then I go and look at my table and see, what do I have? I have a side length that is the square root of 5. Square root of 5 is across from a 45-degree angle. So across from a 45-degree angle, I'm going to write square root of 5. And that tells me that A equals the square root of 5. So then A equals the square root of 5. And then A times square root 2 is going to be square root 5 times square root 2. But that's not simplest radical form, right? Because we can put those together. So this is the square root of 10. All right, and then all that's left is to actually answer the question, x and y. So x and y, what are they? Well, I see that y is a leg of the triangle. It's touching the 90. So y is going to be the square root 5. And so that means that x is across from 90, so x equals the square root of 10. Okay, so that's your first two examples. I have some more on the back, and they do get a little trickier. And I do want you to rationalize denominators, which means you cannot have a radical in the denominator. But rationalizing a denominator is actually not all that bad. I'm going to show you a shortcut for that too. Okay, so we have a special right. So you can tell you have a special right because the 90 degrees and the 45. So I'm going to set up a grid. A square root 2. And then I need a starting point. This starting point is 9 square root 2 over 2. And that is across from 45 degrees. So that is A, right? So 9 square root 2 over 2. And 9 square root 2 over 2. And then on the last part, for the 90 degrees, is still, A is 9 square root 2 over 2. So I'm still writing that for A. 9 times the square root 2 over 2. And then it's times the square root of 2, right? Because that's part of the formula. And if when you have fractions, if it helps you to write both pieces as a fraction, but one of them's not, that just means you put it over 1, right? If there's not a denominator, that implies that the denominator is a 1. Because when you multiply fractions, you multiply straight across the numerator and straight across the denominator. Multiplying fractions is easy. It's the adding and subtracting that's tricky. All right, so I'm going to do this. I want to multiply the numerator. I have 9. Square root 2 times square root 2 is going to give me the square root of 4. And what's the square root of 4? 2. So I'm going to write it as 9 times 2. Or I could write it as 18. Either way is fine. But in the denominator, I have 2 times 1, so that's just 2. And so then I write it again as 2. All the steps across the numerator, the denominator, or if you want to do both steps at once, your preference. Now I have 9 times 2 over 2. That means I have a 2 in the numerator and a 2 in the denominator. And so I'm going to cancel them out, and that just leaves me with a 9. So a square root 2 equals 9. Isn't that crazy? So that means that x is 9. And then we already have that y. We know y is 9 times the square root of 2 over 2. So there they are. There's x and y.